the session. So what is the, let me set the agenda, like what I'm going to cover in this session. So, so as the name says, Java concurrency evolution. So what we are going to see is how Java has implemented the thread multi concurrency in its system, right? There are multiple patterns to implement the concurrency into the language. Okay. So how Java has implemented it, and what in different versions of Java, how it evolves down the line, and what are the best practices that we should be using in order to implement the concurrency in our programs, right? So these all are things that I'm going to cover as part of it. So yes, so I can take to the next slide. So first of all, as some people may know, or some people might not know. So to cover the entire audience set, I just want to touch upon concurrency, because sometimes we feel like, okay, concurrency is always a parallelism or something like this. Just want to avoid any confusion. So what is a concurrency? Like normally when we do some, we are a consumer of concurrency by default. When we start an operating system, we run applications, multiple applications, right? It is actually, we are implicitly doing it. Applications are running concurrently into the operating system. Okay. So what is happening behind the scene? So in the earlier days, like 25-30 years ago, like we used to have one CPU with one core, only one CPU core. Okay. So in that case, what happened? Like if we start an application, and if we start another application, like suppose I've started a Word, and then I've started MS or Excel and parallel, right? And if I'm doing activity in both these applications, so what happened? If you see this particular diagram, like, so this is representing one core CPU. Okay. So where the concurrency is achieved via context switching. Basically, we have a CPU and we have a scheduler. Okay. So that scheduler is responsible for scheduling an application to be run within the CPU. Now, since we have only one core, one person doing the job, right? So, and if we want, if we are giving multiple tasks to that particular person, so what it does? So it does some piece of the task, and then switch to another application, then switch to another one. So context switching is happening. So from our perspective, from the consumer perspective, it looks like this is parallelism, right? Pure parallelism. But that is not the case, because we have only one CPU core, and it's internally doing context switching. So that is also one way of having the concurrency. So concurrency is seemingly parallel approach first, where we have context switching in case we have one CPU core. But nowadays that is not the case. We have more than one CPU cores, even 4, 8, 32 CPU cores are coming up, right? So we do have multiple CPU cores. So in that case, what would happen? Like it could happen that my one application is running entirely in one core, other application is running in parallel in another core. Okay. So when I say applications, we can have application. When I talk about application, so it is basically multi-processing. Okay, multiple processes are running. But if I'm talking about task, so it is like within the application, we can have more than one task, or we can say task is nothing but a thread in technical terms, if I say. So if my application is doing multiple job at the same time, or multiple pieces of work at the same time, then we call it as a task. Like we divide our logic in such a manner that the logic, a couple of functions can run in parallel together. So these functions we normally, in a layman term, we can say that they are basically threads. They are basically tasks. So when I talk about task, it becomes multi-threading. When I talk about applications process, it becomes multi-processing. Okay. So in both of this terminology, ultimately it is a concurrency only. Okay. So that is the basic idea behind the concurrency. Just want to move to the next slide. Okay. So I hope you understand this concurrency very well. So now how Java supported the concurrency, what are the different patterns a language can have, what are the different patterns to implement the concurrency by a particular language or some library. So here we have multiple patterns. One is the shared memory model, where we have like, okay, two threads are here. They are sharing the state, they're sharing the memory. So for example, suppose I've written a program of you can have like a stack. You can think of it very simple. Let's think about a counter. one counter I have created, okay, program where I've created a class counter, and in the class I have created an instance variable like class level variable as count. Okay, so as soon as I create a class level variable, what we are saying that it is a shared memory location. Okay, it is a shared mutable state where more than one thread, more than one worker can share it. Like one thread can change the value of count to +1. Another thread or another task can change it to can do it -1. Correct. So in that case, this is shared memory model. Means they are both this task or more than one task is going to look upon the same memory. So this is the one way of achieving the concurrency. Okay, because we have more than one task or more than one application running in parallel. Correct. So this is one approach. Second approach is message passing. Message passing is nowadays famous. Like we are having a actor model and we have a framework like Aka framework, right? Aka library. Right. So this is a message passing where to manipulate something, we just pass on the messages between two threads, right? Instead of actually looking upon the actual memory and sharing the memory between two threads or two multiple tasks. So in that case, so we just pass in the message to whatever needs to be manipulated. So that is the case with actor model or message passing model. But how Java does it? Java adopted the shared memory model from the start of its implementation of the concurrency. Okay. So secondly, what it does basically, as soon as we write a code, normally we write a code thread t equal to new thread, and then we do t dot start, right? So as soon as we do t dot start, like as soon as we call this method, like let me just open this one. So this is a low level construct Java thread creation. Okay. So normally we create a thread by simply declaring the object of a thread class and then simply do thread dot start. Okay. So as soon as we do thread dot start, what it does, every operating system, whether it is Linux, Windows, every operating system has their own API, low level API, which creates the thread. Okay. So what Java does, thread.start function internally call the operating system level thread function. Okay, like in case of Linux, we have pthread API, pthreads API. Okay, so Java, if I'm sitting in the Linux machine and running the Java program of starting a thread, and as soon as I do it, what it does, it calls that C library, that POSIX thread library, pthread library is written in C. So Java calls that C library using JNI, Java Native Interface. Okay. So it calls that library to create the OS level thread. So Java itself is not creating a thread in its virtual machine. It actually creating the thread of the underlying operating system. So it is a very expensive operation, and I will talk about it when I lastly come with the Project Loom. So it is an expensive operation, and it's again dependent upon the native threads. So this is what I'm trying to say here. So it creates the native threads via thread class. Now, this is the journey where I say that virtual threads and platform threads, particularly these native threads that renamed as platform threads in Java 19 and virtual threads concept come into picture. So here we are saying that threads now will get created into the JVM itself, and then they will be mounted into the operating system thread. So there's a different fundamental concept in creating a thread. So in Java 19 with the name of Project Loom. Okay. Now this is how the Java supported the concurrency. So let's talk about the roadmap. Yeah. So let's talk about the concurrency evaluation. Yes, we will talk about best practices and all. Before that, we should have a clear picture what all classes, what all packages we have in Java that we can utilize. What are the low-level constructs? What are the high-level constructs? When I say low-level means going directly creating ourselves as a thread using a thread class or runnable, etc. Second is like high-level construct, which is Executor Framework. We have CompletableFuture approach, right? All these things are high-level way of doing things where low-level granularities we don't have to worry about. Okay. So in Java 1.1, it started this journey of concurrency where Java introduces certain classes for creating the thread with the help of native threads. So yes, thread group, runnable, everybody might be aware of it. So these are the way we usually create threads. And major addition comes in Java 5, where we have java.util.concurrent package, which includes most of the goodies related to multi-threading. So whenever I talk about thread, like two tasks trying to share the same object. Okay. So but the same example, counter example, right? So what we are saying that two thread is sharing the counter variable. Okay. When the sharing come into, as soon as the sharing thing come into mind, then you can think of it that there can be a race condition. Okay. It can happen that thread one increment the value of this, which might not be visible to the other thread. Okay. So all these things are basically a challenge in the concurrency world. This challenge is solved by having this kind of construct, like concurrent collection has been introduced, concurrent hash map, which is a very good collection that take care of the concurrency within it as an abstract. So instead of using hash map, we should use concurrent hash map, right? When we go into the world of multi-threading, when we say that, okay, this particular object is going to be shared among multiple threads, and instead of creating hash map, we should create concurrent hash map. Okay. So a visibility problem, there is a visibility problem. So I will talk about it in other slides as well. So just I'm saying that there is a synchronization problem, concurrency problems. To solve these problems, we have concurrent collections, atomic variables, synchronizers, lock API. All these are introduced as part of Java 5. Okay. And then in Java 8, we have CompletableFuture, which is a best practice. Okay. And we should adopt using CompletableFuture. Okay. So yeah, so CompletableFuture is equivalent to promises in if I compare it with the JavaScript world. So it is basically saying that, okay, I'm going to execute the task, but you don't have to wait for the response. You don't have to wait for it. So let me complete the task. And then once I'm done with the task, I will call that a handler. Okay. So we are not waiting explicitly on it to complete. So that way it is more of asynchronous approach by using the CompletableFuture. Okay. So these are the interfaces basically. This completion stage is an interface. Okay. So in Java 19 has introduced the different approach of creating a thread. So instead of creating a thread using thread class will be used, but instead of there is a concept thread.off virtual. Okay. So you can explicitly create a virtual thread and make use of it. And there is a benefit, performance benefits, and a lot of benefits of using virtual threads in Java 19. But yes, so let's stop. Let's stop here. If any, as of now, are we good with whatever I've delivered so far? Because that is more of a touch base on what is concurrency is all about, how the Java evolved in the concurrency world, what are the basic constructs, low level and high level constructs and packaging structure. Important classes, I would say. And the recommended practice is to use Executor Framework, CompletableFuture. All this thing, yeah, these two are majorly we should focus on. And low level constructs comes in where we have to use lock API, synchronizers, and all these things. These are low level constructs. If it is needed, then we can use it. So yeah. So yeah, so let's talk about creating a thread. Just want to touch upon this because this is a big to start with, right? And then we'll talk about the problems and the possible best practices. Okay. So what we are saying that, okay, the basic approach, the start approach is to create a thread with the extending a thread class. But again, since Java do not support extending more than one classes, and if we are using this way, then we cannot extend other classes, and this is a brittle approach. So that's why the first approach is directly using it. The second is simply implementing the runnable interface and then implement the run method. So you can think of it like we start an application with the help of main function, right? We code it into the main function. This is an entry point for an application. So whenever our application boots up, like Java program boots up, it comes with one process and one thread. One thread is main thread, correct? So main function itself represents a thread. You can think of it like this. As soon as I introduce one more method, run method, with the help of runnable implementation, like this, in this case, we have implemented, we have class name as main, implements runnable. As soon as I am implementing it, introducing run method. So what I'm saying that this run method itself will represent a unit of work that needs to be done by a thread. Okay. So I created a thread class, and then pass on the object of this runnable interface. Okay, and use thread.start. So what it does, it automatically goes into this run method, like the way we have main method, right? As soon as we start the program, we have a main method. Similarly, as soon as we start the thread, we have a run method. That run method of whatever object we have passed in. Okay, so that way it will create two threads. One is the main thread, okay, by default, and second is this thread, which I created explicitly. Okay, so so yeah, so we'll come across the use case of it. But yes, this is the low level approach. And in case of Java 8, what Java 8 does, we have functional interfaces concept in Java 8, right? Where every interface needs to have a single method declaration, where this entire public void run, this entire thing, I can have it within this directly with the help of lambda expression, right? So we can simplify this logic a little more by using the Java 8 construct. So yeah, if I talk about these are the important things that comes into picture. When I say sharing of memory, something is getting shared between two tasks, then there is a problem of synchronization. Basically, what it means that if I happen to put it on the whiteboard, sorry, this is a whiteboard here. It's already open. Yeah. I have to happen to share here. Okay. So what we are saying that how the memory model is. So we have a memory model. I just want to create that block diagram. Okay. Uh, what we have, like we suppose we have CPU core, where two CPU. Okay. So CPU now it has registers within it. Okay, registers are small chips containing memory locations. Then we have L1 cache. I just want to make it simple. We can have L2 cache, L3 cache. Then we have a shared memory. Okay, this is it. You can think of it as a RAM. Okay. So now we have thread T1 and thread T2. Okay. And they are sharing the common variable. Like common variable is sitting here in the shared RAM. Okay, shared memory, common variable is it. So these two threads. So we have a single application. Okay, Java application. We have two threads, T1 thread and T2 thread. Okay, so it is sharing the common variable count. Okay, now what would happen? Like suppose what we does, we have two run method. In one run method, T1 is here. T1 is incrementing the value of count to doing count plus plus, and T2 is doing count minus minus. Okay. So they are sharing the common variable count, and one is incrementing, another one is decrementing. Now the sequence of operation, like the way I does, I talk about. We have two CPU core, right? CPU 1 and CPU 2. CPU 1 and 2. Okay. Now these two threads can either run they can run in parallel, right? They can run in parallel in two different CPU core. What would happen? It may happen that the count plus plus expression and here can come in parallel. Okay, so that could be the case. So in that case, suppose the count value is 0. So at the same time, what it does, it may increment it to 1 and it may decrement it to -1 and reading the same value, right? So these are the problems in shared model, where the variable value, because T1 doesn't know what T2 does, right? So and T2 and T does not know whether the T1 has a hold of count or not. So in the sharing model, these are the common problems in multi-threading on concurrency, where the race condition would happen, like T1 can increment it and make it 1, but the incremented value is not visible to T2, and T2 still decrement it from 0. Okay. So the final value comes out to be -1. It may happen, right? So to solve these problems, Java has introduced multiple synchronization constructs. In that case, multiple synchronization constructs. So let me go back to the slide. So multiple synchronization construct means like it introduced some important keywords. Synchronized is one of the keyword which can be applied in multiple way, okay, into the program. The second important one is the volatile. Third is the atomic variables. Then it has introduced log API, which is basically there is some drawback in synchronized approach using the synchronized keyword. So log API can be utilized or should be utilized, I would say, from the best practice perspective. We should not stick to synchronized. We should go with the log API approach. I will talk about it in the another slide. And then it has introduced concurrent collection, where it says that if we are used like in this case, synchronized concurrent collection approach, what it says. So instead of count, if I happen to have hash map, right? Instead of count, if I happen to have a hash map here, okay. So they have said that, okay, either solve the problem from the from using the synchronized keyword or log API, etc. Means applying the logs on top instead of solving just the sharing approach. We can also make this variable, whatever variable I'm using, making this as concurrent friendly. Okay. Basically internally it has a construct that, okay, only one thread can manipulate me. Okay. If T1 is coming to me, only T1 can manipulate me, and I get hold of it as a log, and but T2 cannot manipulate me at the same time. Okay. So either we have a behavioral construct like synchronized, log API, etc., or we have a variable level construct like volatile keyword, atomic variable, concurrent collection, right? So these are the couple of approach that Java have applied and gives us the classes to solve this problem of synchronization. Okay. So yeah, so in another slide, there is one example I've mentioned here with the help of a small snippet of code. I think it's little small for you to look into that, but I will cover it from here. Try to cover it. So what the same example I've created, like using the count variable. So what we are doing here, we have a class that has a count variable as an instance variable. Okay. As soon as I create an instance variable, this is a shared memory, shared mutable state. Okay. So this count variable can be manipulated first of all. Okay. Secondly, it is declared as an instance variable, so it is a candidate for a shared location. Okay, that will be shared across the thread. Okay. So what we are doing in the main method, we are creating an object of this class, and then we are creating a thread. A thread is so we and passing on the runnable implementation. Directly we can pass on the runnable implementation. So in the previous example, we have created the object of a runnable class. So instead of that, we can directly create it here itself using anonymous classes approach. So in this, what we are doing, we are trying to print from 0 to 1000, increment from 0 to 1000, this count variable. Okay. With the help of increment method. Okay. The second, also doing the same thing. It calls the same method, increment method, and also trying to increment it. Okay. Now, what if, so assume that there is no synchronized keyword. Okay. So in that case, what would happen? The same, the parallel example I've given. The thread 1 will increment the value from 0 to 1, the count variable. If thread 2 happens to be in parallel, then it may also increment the value of count from 0 to 1 only. So ideally, if they run in sequence, the count value should be 2, correct? So thread 1 will increment it to 1, and then thread 2 will increment it to 2. So ideally, it should be like this only. Okay. But if we do not have synchronized, so this is a race condition. This is a problem in the concurrent programming, where two threads sharing the same memory location tries to access it and manipulate it. So this is the problem. To solve this problem, what we are saying, like this synchronized keyword has been introduced by Java, and this synchronized keyword we have to we can either apply on the method level like the way it is shown here, or we can have it in a separate block. So we'll talk like in the we can have it in a separate block. Let's understand this one because let's keep it simple. So if I use the synchronized keyword, as soon as I use the synchronized keyword here, what will happen? So when it enters into this block, the T11, as soon as synchronized example dot increment, this method is invoked by the CPU, like this invocation is happening. So it will take a lock, like the lock. Every object has a concept of lock, like monitor object. Okay. So monitor flag, every class has a monitor flag. You can assume it, think of it like every class has a monitor flag. Okay. So as soon as this function is getting called, so this particular thread T1 will get hold of the flag. Okay. It will hold the flag and then doing the increment. At the same time, if T1 comes up while it is incrementing, this particular log, say it will see this as a logged because T1 has already taken the log, correct? So T2 when it tries to call the same method whose lock is already taken, so it is not allowed to call this increment method. So it will go into the wait state. Okay. So once it is done with this execution of count plus plus, so the lock is released, and then second thread can invoke the same method increment. And likewise, we can have a parallelism plus sequential ordering of events, like count will be 1, then count will be 2, like this. So there will not be any race condition by using the synchronized keyword. Okay. So this is one way of achieving synchronization by using the synchronized keyword, right? But this synchronized approach is having little challenge here. Like if we have to unlock this, it can only be applied on the if I talk about the lock API, let's talk about the lock API. So here, this is a synchronized one. If it happens to be on the method level and at the block level, suppose a piece of code needs to be protected, then we can apply at the block level using synchronized keyword. Okay. Now, if so, we see that okay, this there are some limitations related to synchronized one, right? Where we cannot have a provision of uh, trying to achieve the lock, something like this. There is no provision like this, or I cannot unlock this in a separate method. Suppose if some other method uh, I have created here, and I want to call that some other method to unlock this particular lock which is taken in this method. Suppose I have public void unlock. If I want to unlock this one explicitly, right? That I cannot do because here the locking is done implicitly because by the program. So I am not explicitly written, right? Key monitor equal to 1, monitor flag, take me the monitor, right? We are not doing anything. Everything magically is done by synchronized keyword. But in case of lock API, Java has introduced lock API. Java.util.concurrent.lock is the package. So that lock APIs are more is a best practice to use. So if you happen to go towards this approach in your coding, in your program, in your application, it is not a recommended approach to use synchronized. It's better to use the lock API. Okay, so why this better? So lock API has a lock interface. A lock interface has been introduced by Java, and there are multiple implementation of the lock API. One of the implementation is re-entrant lock. Okay, re-entrant lock is the implementation. Here, the example of this is written with the help of re-entrant lock implementation. So here the exact program, this program is written with this approach where we are doing the same thing again, incrementing the method. There is no change in this block, but here the small change. We have explicitly created the lock object, re-entrant lock object, and then making use of this lock object to take a lock. Lock.lock. Lock is a method on this object. So we are explicitly saying that, hey, I need a lock because I want to execute a statement which manipulates the shared variable. Okay. So only
Hi,
that
no.
particular piece.
Sorry to interrupt. Could you please maximize the PPT page? That would be great.
Mm, so that is the problem, guys.
Anu, click on present. What is happening?
It actually blackouts. If I click on this, it blacks out like this. It's visible, blacking.
Just give
Yeah,
me
it's
1 minute.
coming up. Okay.
Yeah.
Okay, fine. I don't know. I was trying a lot, and now it is not working. I don't know. Like, it's visible now, right?
Thanks. Yeah.
Yes.
Yeah, something magic happened. I don't know. I was trying a lot yesterday and all. Okay, I hope this makes sense right now. It's visible, right? Yes.
Yes,
Yep.
Anu.
Okay. So in this example, what we are saying, we have explicitly stated our intention. Like, hey, I need a log because I want to execute a statement which is accessing to the shared location. Okay. One thing to keep in mind, if I'm not writing a statement which is not accessing a shared location, okay, like I'm making a call, certain call, I'm logging something or some operation which I am performing, which is not sharing, which is not accessing the shared variable, okay, then there is no need of applying the log. First of all, okay, I happen to see the code in the reviews, etc., in my past organization as well. There is a lot of logic which is written within the method which is not even requiring the synchronization. Okay, so always remember that just place that particular piece of code which requires locking, which is shared, which is accessing a shared variable. Like I'm incrementing it, decrementing it, manipulating the variable value, etc., which is shared. Okay. Then only go for it. Otherwise, not. Okay. Try to minimize the surface area of the locking. Okay. So this is what the example is. I just want to do this locking. So I have applied the lock.log on this particular. There could be n number of statement within this function, for example. Right? Although this is a very simple example increment, it could be like I'm doing hundreds, like I'm doing like 20 lines of code within this function. Only couple of lines of code require this locking. So in that case, you just apply the lock within this couple of lines only. Okay. So this is the best practice would say. So here what we are doing, so log.log count plus plus, then finally block is written, because if somehow some exception happen in this line, I should not be in a state where I could not unlock it, and all other threads which are waiting for accessing this count will block forever. Okay. So that's why finally will always be executing, correct? So in the finally block, we have to unlock it. So what is the benefit of using lock API? This lock.unlock, as you see, this is a method on top of an object. This can be invoked in some other function as well. Means not, it is not necessary to unlock it within this function only. I can say that, okay, I am applying a lock here. If my logic is in such a manner that I can unlock it in some other method. Okay. So this is the flexibility and explicit statements we have. And also we have multiple implementation of lock, like read write lock. If I just want to log for a reading purpose, if I just want to log for only writing purpose. So that way we have other implementations as well. So this is lock API is more flexible compared to synchronized one. And so that's why we should prefer lock APIs over the synchronized approach. Okay. So this is what I just want to highlight, because there are a lot to cover. So just keep it simple, like we should go for lock API rather than synchronized. Okay. So yeah, so then comes few more things. So Java simply says, like, okay, there is good thing that we can create thread using thread class, we can create thread using uh, runnable, we can make use of the synchronization construct ourselves to implement n number of things, correct? But there is a there could be a different approach, right? So for example, I'm just putting on the board, just create a new document. uh, so what if suppose you are writing a code and your requirement is to create 100 thread. Okay. So you have some requirement. Okay, there is a 10,000 you can say uh, request to be made. Okay, underlying request to be made. So you can say, okay, I can create 100 thread which can do 10 requests each. Okay, for example, this is the requirement. So what you have to do, what you will do, end up doing, you will make use of the normal thread construct, like creating a class with the help of thread class, and then create a 100 thread within the for loop, and then within the run method you are going to do this, correct? So, and the lot of things you have to take care of, locking, unlocking, all of these things. A lot of low level things you are writing it, but you do not, you more of, if you happen to see your code, you will see that less of your business logic, more of your threading is happening in the code. Okay, so not a clean approach by using the low level construct when such kind of requirement happen. Okay, so rather than that, they come up with an executor kind of an approach. Okay, so what it says that, so in the lower construct we talk about thread and we talk about run method. Okay, so this represent is more of a task, and this is more of a worker who is going to execute the task for you. Okay, but this is the older all we don't think in terms of worker and task. First of all, we think normally in terms of thread and run method, like this is what our mindset is normally. But in executor it says that let's give it the name, the terminology, that it comes up with a concept of thread pool. Okay, so it says that rather than creating a 100 thread, it comes up with a thread pool. It says that we can have a pool of threads like T1 to T10. Okay, pool of threads. They act as a worker. Okay, they act as a worker, and there is a queue of task. Okay, there is a queue in which you can submit the task. Okay, I would say that like task 1, task 2. Okay, there is a set of tasks which is within the queue, and there is a worker pool of threads which contains this worker. So it says that by using this framework, executor framework, what we can do, we can create a pool of threads, we can create a set of tasks and submit it into the queue, put it into the queue, and then in that case you just have to tell the executor framework, hey executor framework, uh, uh, assign the task, assign the thread, basically worker, to a task. Like T1 is going to execute task 1. There is no proper ordering, I would say, like basis on the availability of the thread to execute a task. Okay, so T1 is going to execute task 1, T2, T3 is going to execute a task 2, something like this. So once it is done with execution of the task, then T1 will be free, correct? Once I am done with this execution, suppose I want to make an API call, I want to collect the data, I want to do something. So once I'm done with that, so this will be free, correct? So once it is free, so it can execute another task in the queue, okay, which is waiting for the execution. So that way, the model is more of like, so first we create a pool, okay, create pool of threads. The first step is creating the pool of threads. Okay. Creating the pool of threads. The second step is to create a task. And the third step is to submit the task to the pool. Okay. Submit the task to pool. Okay. So this is the approach that executor framework says. So in this case, you are not explicitly creating a thread, first of all. Okay. You're creating a pool and saying that, hey, I need a pool of 10 thread. First, I need a pool of 1 thread, single thread pool. Okay. There is a different pool implementation where I can say that I need a fixed thread pool. I need 10 threads, 10 pool of thread. I need a single thread pool. एक ही thread I need only 1 thread pool. Okay. I need a cached thread pool. Okay. So there are different thread pools that we can decide to create, and it will create it for us. And then we create a task with the help of again runnable or callable. So there are two type of tasks. In this case, we have only one type of task, which is a run method approach. Okay, so it is void, always void kind of approach. Okay, but here we can have a return statements like return type. So we have a callable and runnable kind of a task. So we create task with the help of implementing these interfaces. Okay, and then we finally submit it to the pool. So basis on the type of pool we have decided, it actually picks up the task and execute it for us. So we are not interfering. Hey, interfering of creating a threads. We are not actually creating a thread ourselves, writing a thread class. We are not saying explicitly that this thread class has to execute this. This thread has to execute this. We are not explicitly passing a runnable to a particular thread in the executor framework. So that this is the difference. So this is the recommended approach. In case if you have to, if I would say that even if you have a single like basic approach, that you can use it instead of polluting your code with the low level construct. Okay, so yeah, so if I go back to the board, so this is what I'm trying to say. So we created a thread pool with thread 1, thread 2, thread 3, thread 4, and internally it maintains a blocking queue. Why? Because this queue is going to be concurrently accessed by these threads. Correct. Here also we have a concurrency problem, because this queue is going to be shared across the threads, because the threads are going to say, suppose thread 1 is free and thread 3 is also free. Now task 2 is the task which is both of these thread can pull up from the queue. Correct. So again, there is a concurrency problem. So it can happen that the queue is empty, or it can happen so something like this. So race, to avoid the race condition, so we are making use of, internally it is making use of the blocking queue. You don't have to explicitly say like, okay, you don't have to explicitly implement blocking queue, I would say. So that way the executor service works. So we create an instance of executor service. We provide the thread pool type, and then we submits the task to that submits the task to the executor service, and it executes. So so that is one thing. So when it introduces this executor framework, it comes up with the future interface. This particular one, future interface. Okay. So when I say that callable has an approach of can return something, right? It has a call method. Okay. Runnable has a run method. So when it returns something, it returns in the form of a future. Okay. Because immediately a task cannot execute and complete, correct? And like the request response, like the normal function executes, right? It returns a future and a future object basically, and it returns me the future object, and from that future I can get the value out of it. Okay. So what we normally do, so we normally do, like, we have an executor service es equal to executors dot new fixed thread pool. Okay. So we are saying, hey, I need 10 thread pool. Okay. Then what we do, es dot submit. Okay. Something like this. Okay. And then we are going to say, hey, we are going to submit the callable. Okay. So just an example. Okay. So it returns me the future object. Okay. So when I get a future object, suppose f is a future object. So to get the value out of it, so it executes some line of code, right? Suppose my task is of 3 lines. So once I'm done with this 3 line, then only I can return it, right? So immediately I cannot assume that it will complete the execution, correct? So that's why we have a future. But the problem with the future is that there is a method get method, okay, to get the value out of it, get the return value of the function, get the return value of the run method, or call method. So to get that value, we need to call a get method. But this get method is a blocking method. Blocking method means that as soon as I call this get method, it will block, means it will not execute the other lines of code after this get method. It will block until this function gets completed. Okay. It will block until this function gets completed. But the problem is that this task is so complex. Suppose doing a lot of activity, it takes like suppose 100 seconds. So it will block for 100 seconds, then only it come out of it. Okay. So this is the get method is a blocking call. So this is the inherent problem with the future. Okay. And we cannot complete it explicitly. Like I cannot say that, hey, I'm done, instead of explicitly marking it as done. Even if it is not done, I cannot say it complete explicitly. I cannot attach a handler to it. Handler means that if I'm done with the 100 lines of code, I cannot invoke another function. Like I have written a function M1. Okay. So I cannot say that, hey, if you are done with this 10 lines of code, please call this function. Okay. So I do not have a callback kind of approach like the way we have in JavaScript, right, in different languages. So that is the problem with future. So to overcome this problem, there is another feature come in Java 8, which is completable future. Okay. When I say completable future, the name itself says it. I can complete it explicitly. Like I can mark this as complete explicitly without even having it completed by the system. Okay. In case if I want to. Secondly, I can attach a function to it. Once I'm done with the execution, I can simply say that call this function once you are done. Okay. So there are different, so there are multiple methods introduced in the completable future, which help us do such kind of coding where I can have a handler attached to the function once it is done. So the best practice approach is that use the completable future. Never ever go for, I would say, I would not suggest to use future. Even if you are using it, so I would say that let's switch to completable future, understand it well, because whatever is we are doing with future, we can also do it with completable future. Because if you say that, this is again an implementation from the future interface as well. Okay. So completable future is the recommended approach along with the executor service. Okay. So this is the recommended approach instead of creating the thread low level construct and creating the thread for after it. So yeah. So any query in this executor framework? I hope people might be aware of it, but yes, I'm just going through what is the best practices and how do we think about it. Okay, instead of low level construct, we should strive to use executor framework. Okay. So yeah, so then what comes the problem? Then one more thing. Okay, we are done with individual functions using the thread runnable. We are done with having a high level construct executor framework. Okay, but how do we make use of this executor service or completable future in case if we have a requirement? Suppose in case of normally what we do in the REST API world, consumer is going to call our API, REST API, and we immediately send a response once we are done, right? It is a waiting kind of approach where request comes to the server, logic executed within a function, whether it is a controller or service, all things needs to be completed. Once it is done, it will respond it back. Okay. Request reply pattern. This is a normally request reply pattern. Okay. What if suppose if you have to send emails to hundreds of users, okay, and you don't have to wait, like the consumer should not be waiting until all the emails are sent. Okay. So in that case, that is what we need. We need an asynchronous approach. Okay. So the earlier approach is synchronous approach where the consumer has to wait for the response to come. Okay, once it is done. So, but the other approach is asynchronous approach, fire and forget approach, where a request lands on the server and the server executes it, and server immediately responded back and internally start the process of sending the email. Okay, so this is the asynchronous approach. Now, how do we achieve the asynchronous approach with the help of completable future? This is the example. Okay, Async Rest API with @async and completable future. So Spring 3.0 introduced @async annotation and @enable async annotation to run a long running process in a separate thread. What normally happen when a request lands on the server, it creates a thread, and we have a again we have a concept of thread pool in the server, and but with this approach, this approach the same, but the thing is that we are creating a thread explicitly and returning it immediately, like actually implementing the asynchronous flow. Okay, so for this to happen, like what we can do, like we can annotate the @enable async on the application level, Spring Boot application main class @enable async, and then Spring 3.2 introduced @controller REST controller annotation. Introduced @sync support to be utilized with @controller or REST controller. So here, what we can do, like in the controller method, we can annotate the controller method with @async, and then we can have a completable future as a return type of this function. And once we are done with the execution of the statements within it, we can do explicit mark the completable future complete explicitly. Okay, the result is ready. So what would happen in this case? If the request lands on the server, as soon as it sees @async, it it internally create the executor pool, thread pool. Okay, it will create a thread pool, special type of thread pool, async worker. I just forgot, but yes, the Spring has created that particular type of thread pool. That thread pool will get created automatically, but you can override it here by passing in the thread pool object within the annotation in the bracket of this @async. Okay, as an argument of this annotation, or you can have it as a separate configuration at the application level. Okay, where you can pass on your thread pool executor, and then what would happen as soon as the request lands on this method, it will assume it will take it as a task, this particular function as a task. Okay, and submit it to that pool. Okay, once we are done with that, once the task execution is done, then it will get completed and return it back. Okay, but yes, here also we do face the challenge of waiting, right? Because but we do face the same challenge, although although we have created a separate thread and doing stuff, but still we have to wait for it to be completed, then it will return it back. So there is an inherent problem this, because it could happen that the filter chain, all those things, because when the request lands on before the request lands on the controller method, it goes through the filter chain, all those methods, right? But those methods are synchronous, right? So this approach is not completely asynchronous approach when I use this kind of @async and completable future, but it's more better approach compared to if I'm not using it. Okay, in case our methods is a long running method, and if I want to implement an asynchronous behavior into the system, then this is the starting point where I can use @async and completable future. I can implement it. Okay, but this is not the purely asynchronous approach. To go with the pure asynchronous approach, then the recommended approach is using the Webflux. Okay, so Spring 5 has introduced the concept of Webflux. Basically, what it does, we have a reactive API. Okay, reactive interfaces, you can say, set of interfaces, reactive API. So Spring has provided the implementation of the reactive interfaces, reactive specification, you can think. Reactive specification has all the languages, not just Java. All the languages in some or other way has implemented the reactive specification. Like in JavaScript, we have RxJS, right? So in Java, we have JavaX, right? In Java, we have just
RxJava.
RxJava, yes. But Spring has also Project Reactor. Okay.
Yeah, actually, we are only left with 1 minute, so can you please wrap it up?
Yeah, I'm wrapping it up. Yeah, last slide. I'm just moving. Okay.
Okay, fine.
Yeah, so what I just want to highlight, like if we really want to go with the pure asynchronous approach, then go for it, Webflux approach. But make sure that underlying services, like whether it is databases or other relevant dependencies, should also be completely asynchronous or compatible with this. Okay, then only it will make sense. So before you actually go with Webflux, read about it, that what are the compatibility with the Spring. But this is the approach where simply it implements the reactive extension. So Reactor is the project and Webflux is the framework. Okay, so this is a simple example that is more performant compared to the earlier example, this one. Okay, so the last thing is Java 19 has introduced the concept of virtual threads. What we normally do, like Java 1.x, I already told you, like JVM creates the thread, OS level thread directly with the help of Java NI with the help of C classes, correct? Underlying operating system classes. But in case of virtual threads, Java 19, what it says that instead of creating directly the OS level thread, I will create a thread myself in the JVM, okay, and which I call it as virtual thread, okay, and this virtual thread I will create, and then once somebody calls the start method or something, this virtual thread will mount into the OS level thread instead of creating directly the OS thread. Okay, so performance is improved, and because we are not directly creating the OS level thread, and there is a concept of mounting and unmounting, because if suppose IO operation comes into the thread run method, then what it does, it automatically unmount the virtual thread from the main thread, and this way it improves the performance. So it introduces thread.off virtual method, thread.off platform method, new APIs to create the virtual threads, and also new APIs to actually execute it. Okay. We have also new virtual thread per task executor, which is another way of saying that create a pool of virtual threads, right? Rather than a normal thread. Yeah. So this particular thing is termed as Project Loom. Okay. So yeah. So this is what the overall crux of this presentation. The major thing is that we should adhere to using the Lock API, Executor Framework, CompletableFuture, and then finally web plugs if we have to go with the Synchronized API. Okay. So yeah, so I'm done with that. Any queries, guys? Anyone has any query? Any?
No, I think Anup, it was a great session from you. I think people now understand that the momentum has been shifted from synchronization towards the non-blocking APIs. Okay, so that's something you guys need to understand now. Based on the latency of the application, nobody insists yet you should use any blocking features. Right? So always go for non-blocking algorithms, non-blocking APIs provided by JDK. There would be some more upcoming, but since again, based on the business use case, you need to see which fits best. Yeah.
Right. But before we actually dive into the non-blocking, I would suggest just read the documentation, not the Google. We normally Google it and first few results we are done. No, read the documentation, see which version you are using, what is the compatibility around it, whether it is a good fit or not, and whether I have a requirement or not. Then you go for it. Okay. So yeah, reactive programming is the approach where we should adhere to. But yes, be sure that we have proper implementation provided by Spring. Okay.
If anybody has any questions, you can do offline as well. But if somebody wants to ask right now, I think somebody was trying to ask.
I was just saying that it was a great session, Anup. Okay, and from the perspective right now, all the people have a good overview of how concurrency works. Okay, so what you can do is, meanwhile, right, you can practice using some of the methods, right, that exist in Java API, right? So you can try with synchronized block, you will try with the reintent lock, you can try with, and whenever we are building Spring APIs, right, we should always use async way, because that way it will be more performant. Okay. uh, I think Anup, you will be giving some assignments to them, right? So they can practice it, and they can see how it works in real life. Okay, and also try to basically I think CompletableFuture is a very nice feature, right? So once you start using it, okay, you will find you should be able well versed with it, that how to return values, right? How can you combine values from different threads, right? And how you can compose a future. So these are some essential things that every developer should know. Okay, so from that perspective, try to research a bit on that, try to do certain programming examples, and then I think you will be all set.
Right. Especially when we have multiple API call in parallel needs to be involved, then go for the CompletableFuture.all method is there, where I can have, okay, all three one go in parallel. So that is the case. So go for the CompletableFuture, read about the documentation and everything to see completable.all off is a good method to look into, right? Okay, I think we are sorted. So guys, if you feel free to reach out to me with the queries, if any, like if you, so because I this should not be a simple session of one-sided session monologue. it should be productive. Going forward, अगर आपके पास challenge आते हैं, best practices के through आप code लिखो, and this is the outcome for us, right?
Anup, there's certain offline queries also being put up in the same chat. So after this session, you can just address those. Because we are already running out of time, but you can just address offline.
I will.
So there's one from Pratap Singh.
Yeah, I've just copied it out and I will reply to him.
Okay, fine.
Okay.
Thanks,
Thanks
guys.
everybody for joining.
Yeah. Bye, guys.
Bye, guys.